Hi, this is Mick West of Debunked.org, and this video is Debunking 9/11 Microsphere Myths. What are microspheres? What do they have to do with 9/11? How do we debunk them, and why should we bother? I shall attempt to answer all of these questions. Microspheres are microscopic spheres. Here's some on a penny. These are made of iron, and they range in size from around 0.5 millimeter to around 50 microns. That's under 1,000th of an inch. That's very, very small. So how do you make microspheres? Well, any sufficiently small volume of liquid will tend to form into a sphere because of surface tension. The smaller it is, the more spherical it's going to be, the more perfectly spherical. Like the tiny drops of water here, if you look at the drops at the top that are smaller, they're a lot more spherical than the larger drops which are moving around. The same thing works with a liquid metal too. Here's some liquid metal at room temperature, and you'll see that the very, very small drops, especially on the right side here, are very, very spherical. If you pour some liquid metal from a high place, like this shot tower for example, it's going to make spheres. Shot towers were used about 100 years ago to make lead shot. They poured molten lead from the top of this tower inside it into a water bath at the bottom, and as it fell it formed into drops. It cooled enough to solidify, and then they caught it in the water bath, and that's made these little balls of lead which were used for lead shot. But the spheres I'm interested in are iron spheres, and iron melts at around 1600 degrees. Here's a video of some molten iron. The molten iron is splashing around, and all the sparks that come out make these little microspheres. You see some very big spheres, but there's also a bunch of little ones in there. To be liquid, it needs to be 1600 degrees or higher, around that, meaning it's white hot. Quick chemistry point. Steel is 98% iron. It's 98% iron, 2% carbon, and a few other little things depending on the type of steel. So we're going to use the term steel and iron interchangeably here. So what do iron microspheres have to do with 9/11? Well, on 9/11, when the Twin Towers of the World Trade Center collapsed, it created a lot of dust. And this dust covered a wide area of downtown New York, and there was a lot of concern in the weeks after the collapse about the possible health effects. These concerns, as we know, were well founded. Lots of people breathed in the dust, and many people later became ill. At the time, the main concern was asbestos, obviously, but we really didn't know what was in the dust. So various people have done a whole bunch of studies trying to figure this out. The first one was done just a month after 9/11 by the Ground Zero Elected Officials Task Force. Then there's a bunch of others, the USGS, this Millet study, another one by Millet, the EPA did one in 2003. Then in 2003, RJ Lee, a consulting company, did a report on 130 Liberty Street, which was a building quite close to the South Tower that was badly damaged. And they wanted to see what was in the dust that was in that building, and they found, amongst other things, some iron microspheres. In 2005, there was another study by the USGS, and they also found microspheres. A couple of years later, the advocates of the 9/11 controlled demolition theory, which are people who believe that the World Trade Center was destroyed by controlled demolition, they noticed these reports that had these microspheres in, and they thought, like, how does this fit in with our theory? How does it fit in with the controlled demolition theory? And in 2008, Dr. Stephen Jones proposed that the spheres were explained by nano-thermite demolition, and that the spheres hence were evidence of nano-thermite demolition. And he published a paper in 2008 on this subject. So how do you get from iron microspheres to controlled demolition? Here's the logic behind that theory. Iron microspheres means molten iron, because you have to have the iron to be molten for the surface tension to form them into spheres. That's true. Iron melts at around 1600 degrees Celsius, also true. Building fires burn at 1100 degrees Celsius, more or less. That's also true. Thermite burns at 2200 degrees Celsius, another thing which is true. All these things are true. Therefore, the argument goes, the iron microspheres come from the thermite. This is incorrect, but we'll come to that later. And the argument goes on, there's lots of them, therefore there must have been some kind of controlled demolition with a whole bunch of thermite, prove 100%. Now, this theory has been around, as I said, since 2008, and it's now 2018, but this theory is still going strong. This is a current page on Architects and Engineers for 9/11 Truth, And they're talking about this paper by Stephen Jones as if it is still current science and if it still does mean what they say it means. And they talk about how they must have had molten metal being sprayed into the air. And they say on their site very specifically this very simple argument, very, very simple and straightforward and logical. High heat results in spherical particles of iron, which it does. Iron does not melt until 1538 degrees C, also true. Fires were 1100 degrees C, also true. And they use this as what they say as being conclusive proof that there was some kind of thermite involved in the destruction of the World Trade Center. Another group of people who are interested in this are the Lawyers Committee for 9/11 Inquiry, which is a bunch of lawyers, and Ed Asner is also on the board, and they strongly believe that 9/11 involved controlled demolition. As far as I can tell, they all genuinely mean well, and I think most of the people in Architects and Engineers for 9/11 Truth also believe well. These are good people. They believe in what they say, and they feel like they're just doing what is right for the families of the 9/11 victims and for humanity in America in general, because they're just trying to reveal this conspiracy to the world and get the truth out there. So they mean well, they're just wrong. What this group are doing now is filing a petition with the US Attorney in New York for a grand jury investigation into the events of 9/11. Here they are holding the petition in front of the courthouse. Here's the petition. And in this petition, they make a very simple argument at one point. They say, the presence in the World Trade Center dust of iron microspheres formed from previously molten iron is physically impossible without the use of incendiary materials such as thermite. This is a very simple argument, and it would be very compelling if it was true, if it was correct, but it's not. There's many, many ways of making iron microspheres. I've made microspheres myself about 10 different ways. But let's take a step back. I am hardly the first person to address this topic. Let's have a look at the long history of debunking 9/11 microspheres. So the first thing on our 9/11 iron microspheres debunking timeline is 1665 with Robert Hooke. Robert Hooke was a fellow of the Royal Society in England, and he wrote this lovely book, Micrographia. He actually invented a compound microscope, a really good compound microscope, and he spent a lot of time examining small things, minute bodies, and describing what he saw and drawing diagrams. One of the things that he studied was iron microspheres. You see right in the middle there's a perfect little iron microsphere. He made the microspheres himself. He didn't need thermite or anything. He made them very, very simply with a couple of methods. Here's the first method. Method number 1, steel on flint. Sparks struck from a flint. What he did was he struck a flint with the steel over a sheet of white paper. He collected the sparks and he observed that they were iron microspheres. You can do something similar yourself. You can get a flint and a steel and you can strike them together, and I've done that. You could also do it with a regular Bic lighter. Now, modern lighters are actually the reverse of the method Hooke uses, and that the flint, what we call the flint, is actually a mixture of iron and other metals, and it's the hard steel wheel that scrapes that and creates the sparks. But the principle is the same. With very little mechanical effort, you can make sparks which make iron microspheres. Every time you strike a lighter like this, you're creating around 100 iron-rich microspheres. And if you put a magnet behind a piece of paper and strike the lighter over it, you can collect the microspheres and look at them with a microscope. Here I'm striking a lighter in front of a penny mounted vertically with a magnet behind it. You can see the sparks, and you can just see the tiny spheres building up on the penny. The penny is mounted vertically so that the flint residue will just fall off. And what's remaining are these tiny, tiny, tiny little iron microspheres, hundreds and hundreds of them. If we compare the spheres that Hooke made in 1665 versus the spheres that I made in 2018, you'll see, they look kind of similar. We also see the flakes of steel that we get from the scraping action. Very, very similar things. So straight away, Hooke has disproven the basic claim made by these various 9/11 groups. You don't actually need thermite to make iron microspheres. All you need is something that makes sparks from iron. And he made it with a second method too. The second method was to throw iron filings in a flame. He describes his method as take some filings of iron and with the point of a knife cast them through the flame of a candle. and then collect the sparks as before. I did this myself. I used my knife, tossed them through a candle, it made some sparks. It's hard to get a lot of spheres from this because it didn't really burn very well, but it did. But I found a better way of doing it was to use a larger flame. So I used a small blowtorch, and I tossed the iron filings into the blowtorch and collected them with a magnet. You see on the left-hand side there's a dark square, a dark patch, and that is covered with approximately 10,000 microspheres just from a few seconds of iron dust in a flame. And here's a before and after photograph with the microscope. The dust that I tossed through the flame is on the left, and what results from that is on the right. As you can see, there's a large amount of pretty small iron microspheres. They are all under 100 microns in size. So Hooke has demonstrated a second way microspheres can form that does not involve nano-thermite or super high flame temperatures. But we know that spheres can only form from liquid metal. How does the iron end up liquid if the temperature of the flame is so low? Well, the answer is iron burns. It turns out the iron itself is making the heat. If you burn a piece of iron completely, it releases 10 times the amount of energy needed to melt that piece of iron. So the sparks you see are iron burning, melting itself and mixing in some iron oxide to make these iron-rich spheres. When iron burns, it gets so hot it melts the adjacent iron and it mixes in with the molten iron and the iron oxide, and it makes these tiny little spheres. It's only going to work with very, very small pieces of iron though, because you need a very large surface area to volume ratio. If you have a large piece of iron, only the outside of the iron is going to get hot enough to melt, and because the inside is still cool, the whole thing isn't going to melt. But if it's small enough, the entire thing is going to melt. And providing the combustion stops at some point, which it will when it runs out of oxygen or it gets too much iron oxide in the mix, then you're going to get these tiny little iron microspheres. So how does this relate to the events of 9/11? In two ways: fire and friction. These are the two ways that Hooke's experiment showed us that spheres could have formed. First of all, in the fire, very small pieces of iron, like flakes of rusty iron or damaged iron, will burn in the fire and they'll make microspheres. Secondly, from friction or impacts, like if iron or steel hits concrete very, very hard or very, very fast, which it would do during the collapse, then you would get lots of sparks coming off, and these sparks will create iron microspheres. And there's also a kind of combination of these two events. If you have some iron that fails under tension, then what happens is the shock wave of the snapping of the iron propagates through the iron and blows off the surface of iron flakes. Then anything that's kind of rusty or perhaps painted is going to blow off the surface, and you're going to get all these little flakes of rusty iron, which will then combust in the fire. All right, now back to our debunking timeline. We did Robert Hooke in 1665. The next set of debunking was in 2008 on the James Randi Educational Foundation Forum, known as JREF. There was a lot of discussion on JREF. There was over 5,000 posts in these multiple threads. I've only listed a few of them here, discussing the topic of microspheres and things like thermite and whatnot. But it's kind of difficult for your average person to find any information here, even though all of the explanations that I'm discussing in this video are actually mentioned, pretty much somewhere in this forum. It's very, very difficult to find them because they tend to get lost in these long threads. So I ended up independently discovering things like the lighter sparks, and I'm pretty good at Googling stuff. So they did, on the JREF, debunk the claim of iron microspheres being evidence of thermite, and quite comprehensively, but they didn't communicate it very well. They didn't really get that information out there. So next on our timeline, we have 2011 and Dave Thomas. Dave Thomas, in 2011, made this video, how to make iron-rich microspheres, not with thermite, but with a lighter and steel wool. He did a very simple experiment, similar to Hooke's experiment with the iron filings, where he took steel wool, and he lit it with a lighter and he burnt it, and it created some iron microspheres. He took photographs of them, he did some analysis of them, and he found that they were pretty much the same as the iron microspheres found in the World Trade Center dust that people had been analyzing. These spheres didn't look that good. They were kind of like big and bulky and had these wires coming out of them, but they were iron microspheres. And there's actually a much better way of doing it than simply lighting it and looking at the wool itself. What you should do is light it over a piece of paper with a magnet underneath it. And then when you burn the steel wool, and it's better to use actual steel wool rather than a Brillo pad of some sort, when you burn the steel wool, the tiny iron microspheres that form will drop and they will collect on the magnet below. Then if you look at them through the microscope, you see a much, much better collection of spheres of all different sizes. You see these tiny, tiny ones which have come from the sparks, and you see the larger ones which have come from the combustion traveling along the wire, and you see some partially combusted wires like the one in the middle with a sphere on the end. It's a much better way of doing it over a piece of paper. And these tiny spheres are very, very perfectly round, most of them. So you have to be very, very careful because they'll just roll off anything that you put them on. So you've got to have a magnet underneath, and then you've got to transfer them to something sticky so they won't come off. Something like a printer label or something like that to keep them in place so you can look at them with a microscope. Now, this steel wool experiment that Dave Thomas did had some important effects in the discussion. First of all, it showed that there were other ways of making iron microspheres, just like Hooke did hundreds of years ago, but now, here it's how on YouTube actually being demonstrated. It showed that fires could make iron-rich microspheres without higher fire temperatures, just a Bic Lighter, which isn't very hot, and you can even ignite it with a piece of paper if you want. And it showed that architects and engineers for 9/11 Truth and Dr. Jones were wrong when they said that the only cause of this was nano-thermite. And because it was a video, it showed this in a very direct way, and it was a practical experiment that was very easy to repeat, very easy to do. And so people could do it themselves, and they could make these iron microspheres, and they could basically disprove this basic point that the lawyers were putting in their petition to the court. A bit later, Dave Thomas did some more experiments. He took some steel beams and he put them in a burn barrel, and he burnt them, and he got some iron microspheres, which isn't really surprising because whenever there's steel around, there's going to be a whole bunch of microspheres from a variety of methods. Now, what I wanted to do after looking at Dave's videos was try to make as many demonstrations of making microspheres as I could, because he did a few. He did the burning steel. He did the steel wool. He even did one with bashing cannonballs together. But there are other methods too. A really, really good way of making iron microspheres is arc welding. This is me doing a little bit of arc welding over a piece of paper again with a magnet underneath it. It's actually better to do it over a water bath, but this works too. Now, arc welding basically makes a stream of hundreds of iron microspheres per second. And how does it do this? Well, if you look at arc welding very, very close up, this is the electrode, what happens is it melts the steel and melts the steel of the electrode, and the two things kind of splash together with the arcing of the electricity, like causing this reaction. And it splatters off these tiny little drops. You see this huge spray of tiny little drops of steel there. Those will all solidify in the air and turn into iron microspheres. And this video is running at 300 times normal, 1/300th of normal speed. So a real speed, there's basically this constant stream of iron microspheres. And if you ever do any welding, you might notice this dark dust forming underneath where you're doing this welding. That's not soot. You might think it's soot because it's kind of dark looking, but it's actually iron microspheres, iron-rich microspheres that collect underneath welding. And you can pick them up with a magnet and look at them underneath the microscope. Arc welding was used a lot in the construction of the World Trade Centers. The tower's central columns were actually welded together along these edge welds, which were like 2 or 3 inches deep, and they had to fill this entire weld with arc welding. And this created basically a constant stream of thousands, tens of thousands, millions, even billions of tiny iron microspheres, and some of those a goodly portion of those would have ended up, during construction, stuck underneath the walls, in the concrete, behind the walls, and they would have been trapped there, safe from the elements so they wouldn't rust, for decades until the buildings finally collapsed and they were released as part of the microspheres that were found in the World Trade Center dust. Not all of them, but probably part of them. Angle grinding is another thing that creates iron microspheres, and this is the friction method essentially. This is very similar to what Hooke was doing in the 1600s with a flint and a piece of steel. It's shaving off at high speed little bits of steel which then ignite, and then they form these iron-rich microspheres. You can do other experiments. I used a used handwarmer, tossed that through a flame, and the iron filings that are in a handwarmer ignited and made these iron-rich microspheres. You can also make iron-rich microspheres with thermite. The video I showed you earlier of molten iron was actually some thermite burning. Thermite is aluminum powder and iron oxide powder mixed together. When it burns, it makes aluminum oxide and molten iron. And it does make lots of microspheres, some quite nice ones too. But it makes a lot of white spheres, and what I call eyeball microspheres, which are white aluminum oxide with a smaller iron sphere inside. If you look at the equations of combustion of iron oxide and aluminum, the end result is twice as much aluminum oxide by volume as there is iron. It's about equal parts by weight, but it's twice as much by volume. So you get twice as much aluminum oxide as you do iron. And some of this is going to form these eyeball microspheres, which are very, very distinctive, and there was lots of them. And this was something that I don't think anybody reported seeing in the World Trade Center dust. And you would kind of expect it if thermite had been used, at least this type of aluminum oxide thermite. Thermite's a lot of fun. You can buy the ingredients online, and you can make it for about $5 a pound. And with appropriate safety measures, you can do all kinds of destructive experiments. Here I'm trying to cut through a square steel tube, and it with some thermite, and it does eventually cut through this tube, and it falls over onto the side. And if we zoom in on that tube on the left there, you can see near where it's all burnt, there's a white patina. Kind of a speckled white patina. And if we look at that closer up, this is it rotated around, you see that white patina is this kind of a white powder. And that white powder is actually aluminum oxide. And if we look at it even closer, you'll see it's a collection of aluminum oxide microspheres embedded in this kind of slab of aluminum oxide and iron. And there's also a whole bunch of iron-rich microspheres mixed in there, but it's more the white aluminum. So we get this patina around any cut that we do with thermite. And this is very distinctive. You see it on the cuts that were made on 9/11 Truth videos. The exact same patina. And this is something that was not reported to be seen on the World Trade Center, where things have failed, where beams and columns had failed. They look like they've been ripped apart. They don't look like they've been burnt apart, and you don't have this patina of aluminum oxide and iron microspheres near the cut, which doesn't even look like a burnt cut anyway. So moving on. This is my wheelbarrow. It's a steel wheelbarrow that's been painted red. And this is the World Trade Center steel. These are the trusses that were underneath the floors. And you can see they have a very similar paint job. They're both painted with this red rust-resistant primer paint. Now, when I hit my steel wheelbarrow with the axe, I used the back of the axe, then these little chips of paint came off. And this is what they look like. And they're red, which is the paint on one side, and on the other side they're grey, which is kind of the rust and the steel. You can see there's a bit of rust there, but it's also the grey, I think, is actually iron itself, iron or steel. And when you burn it, this coating tends to burn off because it's very, very thin. So it burns in the way that the steel wool will burn, because it's got this very low volume to surface area ratio. And if you burn it by tossing it through a flame, you get these little iron-rich microspheres. And we know they're iron-rich because they're attracted to a magnet, and they're shiny. So you would expect to find both these type of paint chips from the snapping of all the steel as it collapsed and bending, and you would expect to find iron microspheres that are formed from burning paint chips. There is also a lot of microspheres that would have formed during cleanup. There was a huge amount of cleanup needed, obviously, because of all this twisted metal lying in the pile, and they had to cut it a lot before they could get it out because it was all kind of jangled together or sometimes still attached to the original structure near the bottom. So they cut it with a couple of methods. One was an oxyacetylene torch, where they cut it with by heating it up with oxyacetylene, and then they use a high-pressure jet of oxygen to kind of burn through the steel itself, and that creates this huge shower of iron-rich microspheres. Another way is using these thermitic lances, which use actually some iron or other things inside this long tube, and they pipe oxygen through it, and that creates a very, very hot flame out the other side, basically almost like a plasma coming out the other side, and that will pretty much eat through anything. And you can see it's being used here to cut on the right, cut through one of the core columns. So there would have been a huge amount of iron microspheres that were on site from the cleanup. Now, of course, this wouldn't affect dust that was in distant locations, but you have to ask, where was the sample taken? Was it an area in which cleanup had been done? And this actually was an important factor in one very famous area of sampling, which was 130 Liberty Street. 130 Liberty Street is the Deutsche Bank building, which was studied by R.J. Lee, who we mentioned earlier. And he has this one table where he lists Fe spheres, which is iron spheres, at 5.87%. It's not really clear what this means because the table is described as statistical p-values. It's not really clear exactly what it means. It says mean of composition, which makes you think that the dust was 5.87% iron microspheres, but that doesn't really make any sense because there's been a large number of other studies, and on average these other studies found about 1% iron, and that's 1% all of the iron. It's not just the iron spheres, though the microspheres. It's the total amount of iron, which would be all the iron dust and flakes and shavings and things like that. So it's not really clear what this means. But another thing is, if you look at actual photographs of the dust, there really doesn't seem to be that many iron microspheres. The sphere you do see on the left there is a glass sphere. And if you look at all the photographs of the dust, you're not seeing 5% iron. You're not seeing 5% spheres even. Spheres are actually relatively rare. So this 5.87% number is rather dubious. Certainly, R.J. Lee did find iron-rich microspheres, and he did actually suggest that they could be used as one component of his signature of the dust because they were relatively common. So there were quite a few. What might they have been finding then, besides the small amount of spheres that other people have found? Well, the site of the testing was 130 Liberty Street. And this was what the building looked like. If you look on the left, there was a huge gash because a piece of World Trade Center 2 fell against the building and gouged out a huge chunk of it, causing a lot of damage, probably creating a few spheres in the process. But it also the building was coated with dust, which is dust from the World Trade Center, not local dust. This photograph on the left was taken 2 days after 9/11. There was a lot of dust there, but this was not sampled at the time by R.J. Lee. Now, if you look on the right, in 2002, when the samples were actually taken, a large amount of the structure of the building has been removed. And to remove that building, those parts of the building, you're going to have to cut a lot of steel. You're going to have to cut a lot of steel and probably do a bit of welding of some temporary structures. So by the time 2002 rolled around and they actually did the sampling, over 6 months later, the site would have been contaminated. So there would have been spheres in the original dust, we know that for sure, and there probably would have been a few extra spheres from the cutting locally done. So is it debunked? And if so, what was debunked? Well, what has been debunked is the conclusion that the iron microspheres could not have come from the fire. Also debunked is the conclusion that these spheres, the presence of these iron microspheres, meant there was thermite. These simple claims have been debunked. Let's have a look at how the claims are made in a little bit more detail. Here's Architects and Engineers for 9/11 Truth, and this is Richard Gage.
As much as 6% of the World Trade Center dust consisted of tiny, previously molten iron spheres.
As we've seen, this isn't actually true. The 6% figure he's quoting comes from the R.J. Lee report, which not only was in a highly contaminated area, but also doesn't tally with the other dust results, which are all showing less than 1% of iron, let alone iron microspheres. So this figure is rather dubious.
What does this tell us about the temperatures generated in the tower's destruction?
Well, as we've seen, it really doesn't tell us anything, because you can get these iron microspheres from a very low temperature fire.
When the USGS collected samples of the World Trade Center dust, they found the iron microspheres. Insofar, the USGS does not have a valid explanation for the presence of these iron microspheres.
The USGS wasn't actually looking for an explanation for these iron microspheres. It simply noted what was in the dust. There was all kinds of things they found in the dust, and their aim was simply to catalogue what was there. And as we've seen, there's a whole bunch of explanations for iron microspheres being found in the dust.
So what do the microspheres contain? Iron is the main element, and then it has smaller portions of aluminum, sulfur, a trace of manganese.
Let's back up here for a little context. Mr. Lobdill is talking about the USGS survey that categorized the various World Trade Center dust particles. In that survey, they found just four iron-rich particles. Of these 4 particles, only 2 of them were spheres. And of these 2, only one of them had the chemical composition that he describes. The 2 spheres, particle 3 and 4, had very different compositions. The analysis that Mr. Lobdill shows is for particle 4. This actually matches particle 1 very closely if we scale it to remove the large carbon peak, but particle 1 is a flake of iron, not a sphere. The other sphere, particle 3, has the same composition of particle 2, which is again a flake and not a sphere, but has a very different composition to particle 4, the one Mr. Lobdill showed. To cap it off, other analysis of other spheres shows different compositions again, like these ones that show huge amounts of silicon. So are we seeing 50 types of thermite? Or are we simply seeing the sphere formation incorporating whatever happens to be next to it or what hit it, stuff like concrete, which would have aluminosilicates and calcium rock in it? The other components could even come from paint, in the case of the spheres that came from burning paint chips, like the ones from a wheelbarrow.
You must have had a much hotter heat source for you to get 2700 degrees Fahrenheit in order to melt the iron.
So yes, you need a very high temperature in order to melt the iron, but the fallacy here is that you need an external heat source. As we've seen, the iron itself, the combustion of the iron in the form of tiny sparks, is what's actually creating the heat source for a lot of the potential iron microspheres. And those are not counting the ones that are formed before and after the collapse with the arc welding and the cutting and the angle grinding. But you don't actually need an external heat source. The iron itself provides that heat source.
To get these molten spheres, your heat source must be something like a chemical reaction.
That actually is true. In the case of the sparks, the chemical reaction is iron plus oxygen, gives iron oxide plus a lot of heat. And as we've seen, 10 times as much heat as is needed to melt the equivalent amount of iron. So yes, there's a chemical reaction, but it's just the combustion of iron.
An exothermic chemical reaction.
An exothermic chemical reaction, oxygen plus iron.
That reacts, in the case of thermite, reacts at 4500 degrees Fahrenheit.
And clearly the combustion of iron and oxygen is more than enough to melt iron. So summing things up, there are multiple ways that you can make iron microspheres. There are ways that would have occurred before the collapse, during the construction, during the fire, during the collapse, and after the collapse during the cleanup efforts. The spheres that have been found are consistent with these various ways, and they're all different, so they're not really consistent with some kind of thermite being used. So in conclusion, the evidence of iron microspheres for nano-thermite has been debunked. This does not mean that 9/11 was not a controlled demolition, nor does it prove that the buildings were brought down by impacts and fire alone. My goal here is not to convince you of that. All I want to do is to get you to think about this one claimed piece of evidence. It's been around for a decade, but it's wrong. If this is wrong, then maybe something else is wrong too. Maybe you should check. So don't change your round about 9/11 just because of this one thing, but consider that not everything you've accepted for all these years is correct. Maybe it's time to take another look.